Hi everyone, welcome to another GCSE physics video by SMARTPATHTUTORING. This is about upthrust and atmospheric pressure. Objects in fluids experience upthrust. When an object is submerged in a fluid, either partially or completely, the pressure of the fluid exerts a force on it from every direction. Pressure increases with depth, so the force exerted on the bottom of the object is larger than the force acting on the top of the object. This causes a resultant force upwards known as upthrust. The upthrust is equal to the weight of the fluid that has been displaced, pushed out of the way by the object. For example, the upthrust on a pineapple in water is equal to the weight of a pineapple-shaped volume of water. An object floats of its weight equals upthrust. If the upthrust on an object is equal to the object's weight, then the force is balanced and the object floats. If an object's weight is more than the upthrust, the object sinks. Whether or not an object will float depends on its density. An object that is less dense than the fluid is always placed in ways less than the equivalent volume of the fluid. This means it displaces a volume of fluid that is equal to its weight before it's completely submerged. At this point, the object's weight is equal to the upthrust, so the object floats. An object that is denser than the fluid is unable to displace enough fluid to equal its weight. This means that its weight is always larger than the upthrust, so it sinks. Submarines make use of upthrust to sink large tanks that are filled with water to increase the weight of the submarine so that it is more than the upthrust. To rise to the surface, the tanks are filled with compressed air to reduce the weight so that it's less than the upthrust. Atmospheric pressure decreases with height. The atmosphere is a layer of air that surrounds the Earth. It is thin compared to the size of the Earth. Atmospheric pressure is created on a surface by air molecules colliding with the surface. As the altitude high above Earth increases, atmospheric pressure decreases. This is because as the altitude increases, the atmosphere gets less dense, so there are fewer air molecules that are able to collide with the surface. There are also fewer air molecules above the surface as the height increases. This means that the weight of the air above it, which contributes to atmospheric pressure, decreases with altitude. Thank you for watching and make sure you subscribe to our YouTube channel.